Welcome to Educator.com. Today we're going to talk about applications of percents. And I'm sure you've seen percents a lot in daily life, and we're going to talk about different ways in which to use those in algebra. The definition of a percent of change is an increase or decrease expressed as a percent. So a percent of change is either an increase or decrease, and it's expressed as a percent. If the new number is larger than the original one, we call that a percent of increase. If the new number is less than the original, that's called a percent of decrease. To illustrate this, if I start out with $100 in my savings account, and then I go out and earn some money, and I add $50. So I add $50 to the amount I had in my account, and then I end up with $150. The original number, the original amount was $100. The new amount is $150, and that was actually an increase of 50%. So that's a 50% increase. Conversely, if I started out with $100, that was my original amount, and I withdrew $50 from my savings account to go buy something, and then I'm left with $50. So that's my new amount. This time, I've actually got a 50% decrease in the amount of money that I had in my savings account. Some other examples would be sales tax. Sales tax is something that's added to the cost of an item, so it can be seen as a percent increase. For example, maybe you're going to go out and buy a sweater and it costs $30. But as it turns out, there's 10% sales tax in some places, so the sales tax is 10%. That means that my sweater was $30, but 10% of 30 is $3. So my final price is actually going to be $33. So that's considered a percent increase because, again, the final number, the new number, or the final amount, is greater than the original amount. And that sales tax resulted in a 10% increase in the price. Percent decrease can be illustrated by the concept of a discount, which is a lot more fun than the concept of a sales tax. A discount is a percent by which the price of an item is reduced. So maybe you went out to buy the sweater and it turns out it was on sale, 10% off. So you're actually going to pay 10% less for the sweater, and that's a 10% decrease in the price of the sweater. Now we're going to calculate some percent changes, starting with an example using temperature. The temperature increases from 50 to 70 degrees. What is the percent of change? In order to figure this out, there's a formula we can use for percentage change. And the formula involves taking the final value, subtracting the original value, dividing all of that by the original value, and then multiplying all this times 100. And the reason that you're multiplying times 100 is you want the answer expressed as a percent. So this is an equation that you should become familiar with, and it calculates percentage of change. Let's apply it to this example. So the temperature increases from 50 to 70 degrees. That means that the original temperature was 50 degrees. The final temperature, or the final value, is 70 degrees. And once you have that worked out, all you have to do is use the percentage change formula. Percentage change formula. So I have my final value of 70 minus my original value, which was 50, over the final temperature of 70 times 100. 70 minus 50 is 20 divided by 70 times 100. This gives me 0.4 times 100, which equals 40%. Something helpful about this formula is that it also tells you if this is a percent increase or percent decrease. Since this number came out to be positive, this is actually a 40% increase in the temperature. If this had come out to be a negative number, if the temperature actually dropped, we would have ended up with a negative value, and that would have been a percent decrease in the temperature. In example 2, we're going to go back to talking about prices and cost and sales tax. A sweater costs $62. The sales tax is 7%. What is the total price? Well, thinking about this, if you take the original price of the sweater and you add the amount of the sales tax, you get the total price. So filling this in, a sweater costs $62. The price of the sweater is $62. And then I need to figure out the sales tax. Well, if the sales tax is 7%, then it's going to equal 0.07 times $62, which comes out to $4.34. Going back to the equation, the price of the sweater plus the sales tax, $4.34, gives me the total price. Adding those up, it's $66.34. So this is actually a percent increase, if we were to figure that out, because this final number, 66.34, is greater than the original number, 62. A coat was originally priced at $140, but it's discounted 20%. What is the discounted price of the coat? Because this is a sentence, again, I want to translate it into an equation, and if a coat was originally priced at a certain amount, I would take the original price, and then I would look and see that it was discounted. So I'm actually going to subtract the amount of the discount to get the final price, or the discounted price. The original price is $140, and I'm going to subtract the discount. In this case, the discount is equal to 0.2 times 140, which comes out to $28. So I plug that in above. $140 minus the $28 discount, the final price is $112. Now, in the previous example involving the sales tax, and in this example, I set up an equation, went off to the side, figured out the sales tax, or in this case the discount, and plugged that back in. But there's actually a faster way to do it. Instead of writing two separate equations here, what I could do is simply say the $140 minus, and immediately plug this in, minus 0.2 times 140 equals, and then solve that. And this is, again, the original price minus the discount. And that gives me the final, which is $112. So this is quicker than doing two separate equations. Either way will work, but it's always nice to know the most efficient way to go about something. This is a longer example, so we have to break this down one piece at a time. A suit was $175 originally, but is discounted 25%. A sales tax of 6.5% is added based on the discounted price. What is the final price of the suit? To the nearest percent, what is the percent of change between the original price and the final price paid, including sales tax? So there's a lot going on there, and I just want to start out by seeing the first question that I'm being asked. And the first question I'm asked is, what is the final price of the suit? I can't address the others until I figure that out. Well, the suit was $175, then it was discounted, and then we had sales tax. So we have several things going on. And translating this into an equation, if I take the original price of the suit, and then I subtract the discount, I'm going to get the discounted price. I won't have the final price, but it's the first step in figuring out the final price. Then, once I have that discounted price, I'm going to add the sales tax to that, not to the original price. Well, the original price is $175, and the discount's 25%. So the amount of the discount will be 25% of 175, just writing it all as one equation, and that's going to give me the discounted price. And that actually comes out to $131.25. Now I take the discounted price and I'm going to add the amount of the sales tax to get the final price. Discounted price is $131.25. And since the sales tax, I am adding 6.5% of that price, which is 0.065 times 131.25, and that gives me a final price of $139.78. So I answered the first question, what is the final price of the suit? Now they want me to calculate percentage change. And remember, I'm going to calculate percentage change using my formula involving the final value minus the original value over the original value times 100. So I go back and I look, I have my final price and I have my original price was $175. So the final price was $139.78 minus the original value. That was $175 divided by the original price, which was $175, times 100, because I'm dealing with percents. And when you calculate that all out, it comes out to 0.2. This all comes out to 0.2 times 100, and that gives me 20%. And it's actually a negative number. Since it's a negative number, what I have is a 20% decrease in the final price, because I had a discount, which took it down a lot, although some sales tax added to it. Comparing the final to the original, it was actually a 20% decrease. Today we discussed applications of percents. Thanks for visiting educator.com.